Section 5.4 is on similar and congruent triangles. So the first thing to look at is just getting some terminology down. If we have a triangle and we decide to label the corners A, B, capital B, capital C, and label the sides little a, little b, little c, we notice that we are saying this triangle has angles capital A, capital B, capital C. We'll also sometimes have it phrased in terms of 3 points. We could phrase it as angle CAB. Angle B is the same as angle ABC. And angle C is the same thing as angle CAB. And that winds up just being a difference of terminology. Sometimes we like to label the angle in terms of the 3 letters. Sometimes we're fine just using 1 letter. And we notice that we have sides. Little a. And we notice that side little a, we could also think of it in terms of the side BC. So we've got sides, little a is the same thing as the line segment from B to C. Little b is the same thing as the line segment from capital A to capital C. And little c is the same thing as that line segment from A to B. And so we can define the sides in terms of pairs of points. We can define the angles in terms of points. We also notice that we could decide to name the angles with Greek letters. We'll sometimes use things like alpha, beta, and gamma to indicate angle measures. And so what we'll do is we can say that this angle A has measure alpha, has measure angle B has measure beta, angle C has measure gamma, but we'll get to that later. Basically what we notice is the actual angle and its size tend to be 2 different bits of notation. So similar triangles, are triangles that have the same shape but not necessarily the same size. So we notice that if we drew a triangle that was 3, 4, 6, and another triangle that was 6, 4, 3, we notice that these are similar. Because they have the same shape. They're also congruent, but we'll get to that later. We notice that they're the same triangle, just changed in orientation a little bit. What we also notice is that if we drew a triangle and said that one was 3, 4, 6, and then the other one was 6, 12, 8, these are also similar. these are also similar triangles. And one way to tell is that the ratios of the side lengths are equal. And we actually have two ways of doing that. We notice that if we compare corresponding sides, we notice that, we'll talk about the idea of corresponding sides in a moment, but we notice that if we take 6 divided by 3, that equals 2. If we take 8 divided by 4, that equals 2. If we take 12 divided by 6, that equals 2. And that tells us that that second triangle is exactly twice the size, well, all the side lengths are twice the size of the side lengths for the first triangle. Another interesting quirk is that if we take ratios of sides within a triangle, the ratios will match. We notice that if we take 6 divided by 3 versus 12 divided by 6, they're both 2. If we take 4 divided by 3, that matches with 8 divided by 6. And if we take 4 divided by 6, that matches with 8 divided by 12. So we notice 4 divided by 3, 4 thirds equals 4 thirds. And here 2 thirds equals 2 thirds. And so what we're going to notice is that if we look at two triangles, ABC and DEF, we notice that corresponding sides are sides that form the same angle, same angles, corresponding angles, have sides that form the same ratios. So pretty much we're noticing the corresponding sides serve the same role in each triangle, corresponding angles serve the same role in each triangle. And so we notice that for this triangle ABC, we notice that if we label those sides little a, little b, little c, little d, little e, little f, we notice that angle A corresponds to angle D, side AB corresponds to side DE, and so on. And so what we're noticing is that we've got some fundamental properties of similar triangles. if two triangles are similar, we know that one, corresponding angles are equal. Two, corresponding sides are all in the same proportion. We'll call that scale factor. We'll talk about that in just a moment. You notice that we had talked about that number 2 when we were talking about the triangle 3, 4, 6, 6, 8, 12. You notice that the ratio of the side lengths is always 2, and so we call that scale factor 2 in that case. So we use the term scale factor for the number k such that the ratio of corresponding sides always equals k. So in practice we notice that if we had the triangle 2, 1, 3, 2, 1, 2. We'll keep it simple. So we have the triangle 2, 1, 2, and we had another triangle that was 6, 6, 3. What's the scale factor? We notice that if we take 6 divided by 2, that equals 3, and 3 divided by 1 equals 3, and so we know the triangles have to be similar. The triangles must be similar. With scale factor k. Sorry, scale factor 3. And so we can sometimes use that. We notice that if we were told that two triangles are similar, and we know that one of them is 3, 5, 6, and the other triangle is if the other triangle has a side length of, let's make it, keep it simple for the moment, 10. So if we're told if the following two triangles are similar, what must the scale factor be? What are the side lengths? And so we notice we can find out 10 divided by 5 equals 2, so we know k has to equal 2, and so now we know that the other triangle, 3 times 2, has to equal 6, and 6 times 2 has to equal 12. And so we now know what the side lengths of the triangle are. That said, we have to be a little bit careful with how we term things. We notice that if we're told that we have a triangle A, B, C, and then the other triangle is M, N, P, if we're told, we'll use the symbol, we'll use this little wavy line to indicate similar. If we're told triangle ABC is similar to triangle PMN, we notice that we can't just treat it as AB corresponds to MN. We have to look at the correct order. We notice that we're saying side AB corresponds to the side PM, side AC corresponds to side PN, side BC corresponds to the side MN, and we know angle A corresponds to angle P, angle B corresponds to angle M, angle C corresponds to angle N. And so we can't necessarily just go by the pictures. We notice we can't just say AB corresponds to MN because we're told the triangle ABC corresponds to triangle PMN, and so you have to abide by that instruction. And so if we were told that the side lengths were 7, 5, 8 for triangle ABC, and then we found out that which side do we want? If we know that side PM is equal to 21, we notice we have to be careful not to compare side AC to side MP. If we're trying to work out what the scale factor is, we have to compare that side AB to the side MP, PM. And so we can say 21 divided by 7 equals 3, and so our scale factor is K equals 3. And then we notice that we can see that that side AB has to correspond to the side, whoops, we already said AB, so the side BC corresponds to the side MN, and so we know that's going to be 8 times 3 is 24, 24, and we know that the side AC corresponds to the side PN, and so you know that's going to be 5 times 3 equals 15. And so you'll notice a lot of questions will wind up having things arranged nicely for you, but they don't have to be arranged nicely for you. They can have things twisted around a bit